In 1935, a young Indian physicist published a mathematical proof that contradicted Albert Einstein's theory about how stars die, challenging the most celebrated scientist in the world with calculations so precise they could not be dismissed. Einstein himself stood before an international conference and declared the young man's work impossible, using his enormous authority to crush what he called a mathematical absurdity. Yet within decades, the brilliant physicist's calculations were proven absolutely correct, revolutionizing our understanding of black holes, stellar evolution, and the ultimate fate of the universe. By then, the scientist who dared challenge Einstein had been driven from the academic mainstream, his career destroyed by professional retaliation, his revolutionary discoveries attributed to others who had the political connections and racial privilege he lacked. This is the story of Subrahmanyan Chandrasekhar, the physicist who proved Einstein wrong about the death of stars, and how the scientific establishment punished him for being right. Born in 1810 in Lahore, British India, Subrahmanyan Chandrasekhar grew up in a family that valued intellectual achievement above all else. His uncle was C.V. Raman, who would win the Nobel Prize in Physics in 1930, making him one of the first Asian scientists to receive such recognition. Young Chandrasekhar, called Chandra by friends and family, showed extraordinary mathematical talent from early childhood, solving complex problems that baffled his teachers. By age 15, he was studying quantum mechanics and special relativity on his own, reading the same scientific papers that professional physicists struggled to comprehend. He completed his undergraduate degree at Presidency College in Madras at age 19, already publishing research papers in international physics journals. In 1930, he won a government scholarship to pursue graduate studies at Cambridge University in England, joining the most prestigious physics department in the world. The voyage to England by steamship took several weeks, and during that long ocean crossing, the 20-year-old physicist made a discovery that would change astrophysics forever. Chandra was thinking about white dwarf stars, the dense remnants left behind when medium-sized stars exhaust their nuclear fuel. According to conventional understanding, all stars eventually became white dwarfs, supported against gravitational collapse by a quantum mechanical effect called electron degeneracy pressure. Einstein and other leading physicists believed this process was universal, that every star, regardless of its mass, would end its life as a stable white dwarf. But Chandra performed detailed calculations combining quantum mechanics, special relativity, and gravitational physics, and discovered something shocking. There was a critical mass limit above which electron degeneracy pressure could not support a star against its own gravity. Stars above approximately 1.4 times the solar mass would not become white dwarfs at all, but would continue collapsing under their own gravitational force, potentially compressing infinitely into what we now call black holes. If you want to discover more brilliant scientists whose correct theories were rejected by the establishment because they challenged powerful figures, subscribe now and activate the notification bell. Every week, We reveal the untold stories of researchers who were right but punished for contradicting the accepted wisdom and authority of celebrated names. Chandra arrived at Cambridge in 1930 carrying revolutionary calculations that overturned fundamental assumptions about stellar evolution. He presented his work to Arthur Eddington, the most famous astrophysicist in Britain and the man who had made Einstein a global celebrity by confirming general relativity through ECLIPSE observations in 1919. Eddington listened politely to the young Indian physicist's presentation, examined the mathematical derivations, and then dismissed the entire theory as obviously wrong. Eddington could not accept that stars could collapse infinitely, that there were processes in nature with no physical limit. The idea seemed philosophically repugnant to him, a violation of some deeper principle of cosmic order. He believed Chandra must have made a mathematical error somewhere in the complex calculations, even though he could not identify where the mistake occurred. Rather than engage with the scientific arguments, Eddington used his authority to discourage Chandra from pursuing this research direction. For several years, Chandra continued refining his calculations, eliminating every possible source of error, and developing the full theoretical framework for what became known as the Chandrasekhar limit. He published technical papers in physics journals that were largely ignored by the astrophysics community. Young researchers interested in stellar evolution were warned by their advisors not to work on Chandra's theory because it contradicted Eddington's views and could damage their careers. In January 1935, the Royal Astronomical Society held a special meeting in London to discuss stellar structure. Chandra was invited to present his work on the mass limit for WHITE dwarfs, finally getting the opportunity to explain his revolutionary theory to the assembled leaders of British astronomy. He spent months preparing a comprehensive presentation with detailed mathematical proofs, confident that once the scientific community saw the complete calculations, they would recognize the validity of his work. Chandra delivered his presentation brilliantly, walking through the quantum mechanical principles, the relativistic corrections, and the inevitable conclusion that massive stars could not become white dwarfs. The audience listened intently, following the mathematical logic and recognizing the rigor of his analysis. Then Arthur Eddington stood up to respond, and everything fell apart. Eddington gave a devastating rebuttal, not based on scientific arguments but on his personal conviction that Chandra's conclusions were impossible. He declared that there must be a law of nature preventing infinite collapse, even if physics had not yet discovered it. He suggested Chandra had misapplied relativity or quantum mechanics in some subtle way. Most damagingly, he used his enormous prestige to frame Chandra's work as the naive mistake of an inexperienced young researcher who did not understand the deeper principles of astrophysics. The scientific community overwhelmingly sided with Eddington. He was a towering figure with decades of groundbreaking research, while Chandra was a 24-year-old Indian physicist with a colonial accent working in a field dominated by white European men. Major physics journals became reluctant to publish Chandra's papers on stellar collapse. Senior physicists advised him to abandon this research direction and work on safer topics. Even Einstein, when asked about the controversy, sided with Eddington, saying that nature would not permit such mathematical absurdities. The professional consequences were devastating. Chandra should have been rapidly advancing through academic positions at Cambridge, but instead found himself marginalized. Fellowship applications were rejected with vague explanations about his research focus being too narrow or controversial. Eddington used his influence on hiring committees to block Chandra's career advancement. The message was clear: challenging the great Eddington had been a career-ending mistake. In 1937, Chandra accepted a position at the University of Chicago, leaving Britain for America, where he hoped to find a more receptive scientific environment. He continued working on stellar evolution and astrophysical theory, making fundamental contributions to our understanding of stellar dynamics, radiative transfer, and black hole physics. But the damage to his reputation persisted for decades, with European physicists dismissing him as the man who had made outrageous claims about infinite stellar collapse. Meanwhile, astronomical observations were gradually confirming Chandra's theory. Astronomers discovered massive stars that exploded as supernovae rather than becoming white dwarfs, exactly as his calculations predicted. Neutron stars were discovered in the 1960s, ultra-dense objects representing an intermediate stage between white dwarfs and complete gravitational collapse. The concept of black holes emerged from general relativity, and physicists realized that Chandra's mass limit described exactly when stellar collapse would become unstoppable. By the 1970s, the Chandrasekhar limit was recognized as one of the fundamental constants of astrophysics, as important as the speed of light or Planck's constant. Every astronomy textbook included Chandra's calculations, and researchers studying black holes, supernovae, and stellar evolution built their work on his theoretical foundation. Yet even as his scientific contributions were finally acknowledged, the story of how Eddington and Einstein had destroyed his early career was quietly forgotten. Arthur Eddington died in 1944, never acknowledging that Chandra had been correct. Einstein died in 1955, also never publicly admitting his error about stellar collapse. Both men remain celebrated as giants of 20th-century physics, their reputations untarnished by the fact that they had been completely wrong about one of the most important questions in astrophysics. Chandra continued working at the University of Chicago for his entire career, producing groundbreaking research across multiple fields of theoretical astrophysics. He wrote landmark textbooks that trained generations of physicists and astronomers. He served as editor of the Astrophysical Journal for 19 years, transforming it into the most prestigious publication in the field. His mathematical techniques and physical insights advanced virtually every area of stellar physics and cosmology. In 1983, more than 48 years after the Royal Astronomical Society meeting where Eddington humiliated him, Subrahmanyan Chandrasekhar finally received recognition for his revolutionary discovery. He was awarded the Nobel Prize in Physics for his theoretical work on the physical processes governing the structure and evolution of stars. The Nobel Committee specifically cited his calculations of the mass limit for white dwarfs, the work that Eddington and Einstein had declared impossible. Chandra was 73 years old when he received the Nobel Prize, having waited nearly 5 decades for the SCIENTIFIC establishment to acknowledge what he had proven as a 20-year-old on a steamship to England. In his Nobel lecture, he spoke graciously about the long road to acceptance, never directly criticizing Eddington or Einstein, maintaining the dignified silence that had characterized his response to decades of professional ostracism. He continued working until his final years, publishing papers and mentoring students even as his health declined. Subrahmanyan Chandrasekhar died on August 21, 1995, at age 84, having transformed our understanding of the universe despite the scientific establishment's attempts to silence him. Today, the Chandrasekhar limit is fundamental to modern astrophysics. Every discussion of black holes, neutron stars, supernovae, and stellar evolution begins with his calculations. The Chandra X-ray Observatory, one of NASA's great observatories studying high-energy phenomena in space, bears his name. Physics students around the world learn his mathematical techniques and study his theoretical insights. Yet the story of how Einstein and Eddington were catastrophically wrong, how they used their authority to crush a young scientist whose calculations were correct, remains largely unknown outside specialized physics circles. Popular histories of 20th-century physics celebrate Einstein's genius while omitting his failure to accept Chandra's theory. Biographies of Eddington emphasize his contributions to relativity while downplaying his destructive opposition to the Chandrasekhar limit. The tale of Subrahmanyan reveals how scientific progress is often blocked not by lack of evidence but by powerful individuals defending their reputations and worldviews. It shows how racism and colonialism affected even the supposedly objective world of theoretical physics, where a young Einstein scientist's correct calculations were dismissed partly because of who he was rather than what he had proven. It demonstrates how scientific truth can take decades to overcome institutional resistance when it challenges the beliefs of celebrated authorities. Chandra was right, and Einstein was wrong. The universe does allow infinite gravitational collapse. Stars do have a mass limit beyond which they cannot become white dwarfs, and black holes are real consequences of general relativity rather than mathematical absurdities. Every piece of evidence collected over the past 90 years has confirmed Chandra's theory and contradicted Eddington's objections. Yet the scientific establishment made Chandra wait half a century for recognition, destroyed his early career prospects, and allowed the men who were wrong to die as celebrated heroes while the man who was right struggled in obscurity. Every time astronomers study black holes or calculate stellar evolution, they use Chandra's mathematics and build on his theoretical framework. The least we can do is remember the full story: the young physicist who proved Einstein wrong, the scientific establishment that punished him for being right, and the decades of silence before truth finally prevailed over authority.